Okay, now this is day 3, and we will explore some of the latent space of our networks. So I'm sharing my screen. I will switch this into English first of all. Okay, great. Now it's connecting. Okay. Okay. So what we're going to do today is we will test our model. So it is also known as inference, evaluation, or testing. So we will try to understand our model, what kind of results are emerged. So we will try to generate some images and videos. And well, in the original definition, in Schultz's definition, there are just single images. I also added here the multiple images part, okay? So this line is giving you multiple images. And first of all, these images are called as seeds. So what is a seed? As you know, we all, when we have all seeds, it's growing up, right? So we will have too many seeds in this one, but we can define it first of all. And I didn't add any forms like that. I add forms here, but I didn't add any forms here. So I'm gonna try to show you how you can also, sorry, yeah, somebody's entering it. How you can also show you generate some videos along with it. So we will see some transformations between the seeds. And well, you don't have to use this one. I also kept this one. If you were using TensorFlow library or any other, you know, runway downloaded PKL file, maybe you need to use in the future this one. I just kept it, but we will not use this today. So don't use that part, okay? We are passing to testing and inference. So we will generate some single images by using our networks, and we will generate some seeds, and we will have some truncation, you know, videos, and we will truncate the latent space. So we will try to understand some of the sections of the latent space. It will select some random seeds. And here you are seeing the code, and outer means in the code, it is actually generating a folder by itself. So here, as you see, this is the part which should be, oops, it can be a little bit tricky though, be careful, yeah, here. This is the part where you should put your paths for generating the file. Let me enter my drive and show you in a more detailed way. For example, here it is in my drive in DigitalFUTURES AI folder, latent space exploration. Please do not leave any space between the names. So write it, you know, as merged. Otherwise, you will get errors. So here is my file. And you are seeing I have already too many files. And when I go it now, I have a seed here. And now I'm gonna erase this file. So there isn't any image file. What does this mean? It will actually generate the file that I'm naming here. It will generate the file automatically. So just give the name of your file that which you want to record, which you want to save your outcomes, okay? Just write the name of the file under your drive. And the truncation, you know, amount here, you're seeing it. So It can be between 0.5 to 1, so you do not need to change it right now. Seeds 20, so this is the number of the seeds, so we are taking it randomly. You can change it after you want. For example, I can make it 119, 300, so it doesn't matter though. Now I'm gonna keep it like, for example, 19. And then the network. This is important. This is the PKL file, your network, your trained network. You should actually take the last trained version. How are you gonna reach it? Go to Drive, and again, under your My Drive folder, go to, oops, where is mine? Sorry, where is it? Yeah, here. And under this one, go to Results. And here, I will take this one, for example. I'm going to copy the path. And I'm going to copy paste it. Now I have the network which I want to use it. And then I'm going to hit again run. And what happens? Because I didn't initiate the process of the repository again, I'm going to just play it. Okay, we will wait for a moment. Okay. Now I'm checking out. I have done this before, so again, this is taking a little bit of time, but not too much. Do not worry. Okay, let's check our latent space. So here, as you see, the images folder generated automatically. And when we get in it, now we are seeing the seed 19. Here is seed 19. You can explore different kind of seeds here. For example, let me just write 300 when I'm not, I am just running it again, and I am not deleting the image file. We will see what will happen. So actually, just, I'm gonna check again the image. Here it is. So it will add also the seed 300 inside of it. So this is the seed 300. And you can explore this single image generation one by one. What I just changed with this definition is, as I told you, I added also generate multiple images so that we can have multiple images at the same time, and we can explore the seeds one by one. And I named in the latent space exploration file under the latent space exploration file as images, and in latent space exploration seed images. And here, let me check this one. Now I'm gonna change the name of the folder though. I'm gonna just write seed, just write seeds, okay? Or yeah, that's it. And then what I'm doing here, well, I have some start and stop actions, and I have again truncation value. It can be between 0.5 and 1, but you can also use 2, 3. But if you want to get, you know, different or funny versions, you can raise it. And what I want to see is between 0 and 300. You can actually make it 1,000 if you want, but it will be too much. Now I'm gonna just create 200, for example, between 0 and 200. I want to see some random seeds. And well, again, to this spot, what you're doing is you're taking the path of your network here. Again, I'm copying the path, and then you're coming here. And what you do is you are entering your network code here with Control V. So you're pasting it, and then the code is ready, and you're running it again. And again, it is loading networks, and we will see our seeds. So as you see, it is generating the images one by one.
Huh.
Again, this is not taking too much time. It depends on the range you want to see. Now we will see between 0 and 200. If you want to see 1,000 seeds, then yeah, it will take a little bit more time. But as I told you before, PyTorch is working really fast when you compare it with TensorFlow, but maybe there are other upgrades in the other libraries as well. So everything is changing very rapidly. I highly recommend you to check out the other, algorithms as well. Maybe you can find faster or cleaner versions, but this one is working really good. Okay, now let's check out our, and here it created the seeds folder. And now, voila. We have the baby seeds here. Do you see our new little cup? So some of them are ready to go. We can literally print them and use them. Some of them needs more training. Well, first of all, we need to translate them into 3D, of course. So this is how it works, basically. And is it going good till now?
Yes.
Okay. Now we will make more explorations. So we tested the model. We find out, we generated our seeds, and we find out the results. Now we will try to understand how can I say, the transformation between them. And we will take one of the seeds and we will try to generate some videos by using them at the same time. And as you see here, again, it is defining the process here as truncation. And again, it will generate a folder by itself because this is author function. And then I'm gonna just check out my drive because I already have it. What I'm gonna do is, it will be too complicated at the end for you to see. What I'm gonna do is, I'm gonna do it like that. I'm gonna just rename this. So yes, so it will generate this folder. And here you can change the seed number though. So you will just pick one of your favorite seeds. Since you generated some multiple seeds before, you can just check out them and you can write one of your favorites here. And then these are the values. Again, you will put the network here and you will actually write the start and stop values for the truncation value. And do not make it too big, okay? Now, the increment value is can be very small, and you will see a very slow interpolation. And actually, start increment is giving us some, total frame numbers. So here you can change this into 1 or into 5. It is up to you. I will try 0.05, for example, right now. And we will see what's changing here. So I'm gonna check out my, oops, sorry. I'm gonna check out my, for example, I used here beforehand another network. Now I'm gonna use the same network which I generated, the latest seeds. Okay. Oh. Do you see when you just select it as it is, sometimes it selects it also? Be careful. That's why I'm erasing it one by one here. Okay, now it's okay. Now it generated another latent space exploration folder. And when we get inside of it, it is generating the frames one by one. And it opened a truncation folder also. And inside of this one, we will be able to see the frames. Here they are emerging. So here we are seeing one of the images, for example, frame 59, and let's check out frame 65. So there's a very slight difference between them. Just incrementing the truncation. Is it working in yours? Are you trying with me?
Mine was just in the last part, generating multiple pictures. I didn't try it.
Okay, so you just got the seeds. Okay, now we have the frames. Just check our folder again. Refresh it. And here you will have your first video. Unit space in your drive. Yes.
Where can I set the number of frames?
The number of frames?
Yeah.
Here, Alexandra, I guess, is talking. So here you will give an original seed, which one you like, and you can play with this one, Alexandra, okay?
Mm-hmm. Okay.
just try to, for example, decrease this one. But it should be always larger than the start value, okay?
Okay, thank you.
Try to play with the range. So maybe we can go on, and then we will explore the interpolation. So we will see how vectorial it is changing, and we will see different kind of animations from frame to frame. And now we have linear interpolation, slurp interpolation, and noise interpolation, and circular loop. Circular loop is giving good results at the end, but it can differ according to your aim and seeds. So let's try linear interpolation. The process is same. So what we're gonna do, actually, we need a folder, and we will again need to change some of the values. And here we will add which frames we want to use. So you can change the seed 10, 19, for example. We can write here 300 if you want, okay? And we will see the change also between them. And we need to change the network, but my network is okay. I'm gonna use this one. It is same as I used previously. So I'm not gonna change it, but if you want to change it, as I told you, go here and just erase it like that. Okay? Don't just select it all together like that, because sometimes it selects all of the code, as you see. And then I'm playing again. I'm running the roll.
While we were waiting, can I ask something?
Yes, of course.
Could you explain a little bit more interpolating? Because it's small changes, but I can understand clearly. I think. What type of changing?
Well, we will actually observe it. Okay, let me just here. You are selecting some of the seeds again in the latent space by using Z vector, yes. And you are here. You are changing very slowly how the image merges between the frames. So you're taking some part of that space. We are exploring some part of the generated latent space here, Jaden. And we could have explored different parts if we change these, okay? So we are defining just some points, some seeds in that space. Maybe after this definition is closed, if I'm gonna see if Janajo is here, maybe we can show it from the presentation from the first day. It can be more clear.
Thank you.
Here again, do you see where we are actually making exploration in the space Z? And here also you are defining it. And again, you are seeing that I want to interpolate between the seeds. And interpolation can be linear, slurp, circular, noise. But here, if it is slurp, you are defining multiple seeds. It doesn't differ though. Again, you can change it, for example, to 15, to 50, okay? And then you need to just, again, write the network. You can also define the frame rate here. So let's see also what will happen with this one. And again, it will create this own folder. Okay, oh, okay. So what we see here through these interpolations actually is like trajectories of the generated, seeds. Oh.
I guess we have some error.
Why? Was I disconnected? Maybe let me try with this one. Well, if you do not define your drive here, do you see it? It will generate, if it works, it will generate the outcomes in the space, in the out folder. Again, this doesn't work. Okay. Now it's connected. Yeah, it's connected. Everything is fine. Okay. Let's try the noise loop. We have the same problem. Okay. Okay, let's check. This is working. Yeah, it's working. I will check out the slurp, okay, afterwards. You go on with the noise one. Okay. Okay, did you start trying with truncation and interpolations?
Yes, I did translation. It was really fun.
Okay, because we will pass to the next stage after the break. Yeah, here. Okay. This is giving funnier results though. And when you are making two-dimensional exploration, circular loop is giving, we are working on three-dimensional objects right now. For example, if you are working on a painting or drawing, if you are trying to transfer the style of two-dimensional, representation mode. So circular loop is giving good results, but again, you need to experiment it because each data set comes with different results. So in the circular loop, you can define again, by the way, if you want to define all the frames, Alexandra, you can add directly in the code. If frames doesn't emerge, you can add directly frames, copy and paste it. You can directly put it to the line. In this one, for example, we will have 720 frames. I can decrease it or increase it. So let me just decrease it. And then we have a diameter, and this diameter is defining different kind of, again, beings, existences. How can I just explore it now? I don't know. I'm gonna say again 300 for this one. And random seeds, well, you can choose whatever you want. I will go with 90. And network here again. Here you can see the network. If you're gonna change the network, do not select it like that. You're able to select it till to a place, but it's becoming harder. So be careful while you're adding your network. And now I'm hitting run.
Can I ask a question from linear interpolation?
Yes.
The seeds that we are giving, this is can be it is the range, or it's just two.
It is actually taking a trajectory. So it is defining a random trajectory between 10 and 300 seeds. So in latent space, there's the z vectors, okay? So we are kind of seeing a trajectory, okay? Of the seeds. Are you there?
Yes, yes, yes.
Okay. Was that an answer for your question?
Yes. Can we add other seeds to this number?
Well, for the linear interpolation, we can't make it more than 2. You can try it though, but I think that would be a little bit complicated, but you can give it a try. But normally think it like from A to B, there's a trajectory, there's a trace, right? So we are defining it linearly.
Yes, thanks.
Mm-hmm.
Ayşegül Hocam, have you finished?
Let's check out. Did we? Yes, we did. So circular loop is more smooth, and you're observing the trajectory in a more detailed way. But as I told you, you need to explore it with your own networks. You will decide which one is working best for you.
As you already know, our main concern is how we turn these 2D images into 3D objects again. So you had the 3D objects, you turn them into some 2D images, and now what we will do with these 2D images, how we can use these 2D images as inspos, inspirations for our designs maybe. Of course, we are using everyday life objects, but please think about them as buildings or facades or whatever you like to work in architectural work. We'll take one or more, any of, I mean, it can be 2, it can be 3, it depends on your choice. But we take at least one image from your set, from your data set. By data set, I mean the export data set of your AI procedure. So we take one image and then basically crop it, just clean the unnecessary parts, and then turn it into a 3D object, first by Grasshopper. So I already sent the chat the Grasshopper definition, if you can download it. Actually, a very basic one. So basic, and you don't even do that much steps to create 3D images. But the thing we like to do here is, with this definition, by just changing the image here, you can get an automatic result. After you do this image sampling part and turning into a surface like up to here or something, you can basically bake it and get the same result. But the thing we did here is, as I said before, by just changing this image here, you will both trim the unnecessary parts, and morph it into a desired shape you like according to your creative process. Okay. So being creative is the main thing here. That's why it's not perfect. And this imperfection is the best part of this algorithm, maybe. Anyway, let me just clean it and continue. Why can't I? And after we do this Grasshopper part, we'll have a brief look at Agisoft. Agisoft is actually a very easy software. I mean, the part that we're gonna use is very easy, so it will take you like 30 seconds to learn, even if you haven't opened Agisoft before. It's maybe Agisoft, but I'm calling it Agisoft, so sorry for the pronunciation. And the thing this Agisoft do is just using the 2D images to create a 3D object. It's not working perfectly with your images, but still, since we are now talking about this creative part, I will show you how you can use your 2D images to get a 3D object. Maybe you won't get one. Maybe if you're lucky enough, you'll get one. And again, we'll have a look at how we can turn our 3D object and take its renders and upload it to Agisoft to get a 3D object. So basically, this is what we're gonna do. And from the website of Agisoft, you can download the software. let me just explain the image sampler process first. So image sampler is something that creates the image data to a kind of data we can use for many different processes. To get this data, the first thing we do is first I'm going to close all of them and create with you once more. By the way, Orkan Hocam, feel free to just interrupt me if you'd like to add something. Okay, so there are many ways to use image sampler, but the main understanding behind it is to create a grid under our image. Of course, since you're all familiar with Grasshopper, there are many, many ways, like 100 ways maybe, to create that grid. But to use the spots, the points under the image, I think the best way for our process is to create series and then cross-reference them. So let's do it once more, maybe. And the count of the series doesn't matter. It just have to match the size of your image. And also the size of your image doesn't matter as well. So after you crop your image, let me just show them also. So yes, these were the images I stole from Ayşegül Hoca. So these were the images I chose. And then I basically crop them. You see, I intentionally crop them like dirty to show you that it doesn't matter, even if this doesn't have to be perfect. So if you like to use maybe the background a little bit, you should crop with that part also. The thing you need to decide here is first, decide the image, which one are you going to use, and then decide which part of that image you will be using. So in this example I prepared for you, I like to just use the cup itself, and I like this image. So after you crop your image in your desired way, let's create the grid, underline it. So to create a series, you just need to double click and write series. As you know, we'll go with this one. Maybe, I mean, you don't have to do it once more. Maybe I don't have to do it once more also, but just show you the names. And I just double click and write the number to create a number slider and basically connect this one to count. Okay. 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 And then let me just open it. I create another series. Since all of your images are in a square format, of course, I make the count of them the same, 60 to 60. You can change it, but if you keep it in a square format, it will be greater. Then with cross-reference, which is as in its name, cross-reference here, this one, I cross these two series to create a series that will kind of multiply these two series that are not actually mathematical, but will help me to cross two data, even if they're not numbers. So after I cross-reference them, I basically construct the points to get my grid. And of course, the construct point is construct point. Construct points. Okay, here, this one with X, Y, and Z. From, I mean, for this part, I won't be using the Z coordinates because I will be dealing with it in the further processes. So since my objective is to create a grid, I use just X and Y ones. And now I'll start the image sampler process. So I double click it and write image sampler. This is image sampler. When you get the image sampler, first you'll get something like this. It's giving you a warning that it's telling now it's blank, so you should add something. When you double click it, you will have this settings window. And in this one, from this file path place, by clicking this three-dotted one, you can go and select your image, basically. Now, I don't want to show you my folders, so I close it. Anyways, I'll go with this one. Okay. So when you select the file from this file path, if you click this Mona Lisa image, it will give you the exact dimensions of it. By the way, after cropping it in Photoshop, I save it as PNG again, so that I can have the outer part of it as blank and black in my algorithm. So that was intentional. The PNG is intentional. You can also save it JPEG, but when you save it, Alexandra is in the waiting room. I'm accepting. Okay. When you save it JPEG, since the background of it is also white, I mean, according to your choice, it can change. But in my case, if it was white, then it will be a great problem for me because I want to use the color differences in the image, the contrasts of the colors in the image, so that I can tell the algorithm to create some bumps, create some height differences according to those contrasts. That's why I want to keep the background blank. So that was intentional. And actually, to highlight this, after you download your image and click this Mona Lisa to arrange its scale, from here, from the channels, if you go to the very last one, which is saying, I think the brightness something, when I come to it, it's not written, but it must be the brightness channel. It will turn it into a black and white one. And that will be very useful for our process because, as I said before, we will be using with the contrast differences of our image to get this bump levels. I mean, instead of it, of course, I mean, you can create your bump maps in Photoshop. But here, what we want to do is just handling everything in Grasshopper. That's why we want to do these additional steps in Photoshop. So here, what we need to do is, and another thing, since in the first part of the algorithm, as I set 60 to my series as a size, as a point number, here I change my domains to 60 and 60, even if it's not 60 to 60. Okay, so after I write, maybe it's like something like this, the 1024 in your case, it doesn't matter, you can change 60 here, and after you change it, just click OK, and you'll have your image. I think my computer is stuck a little bit right now. I don't know why. Okay, now it's working. Am I going too fast? Is it or too slow? You can just run.
Yeah, I think I'm able to understand. Thank you so much.
Okay, great. So from now on, we have our image. Let's open it also. But of course, we won't see it. So now what we need to do is, I have my points. And when I connect my points to this image, now what image sampler does is take these points as the input data and turn this image into those points. Okay, I cannot see it right now. Let's see if I can see it in preview. I think I'm just trying to see it, but maybe it won't be possible. Just check. şunu bağlayacaktım. Dur. I think it's not possible in this part. We need to have some additional steps. Okay, anyways. So even if I cannot see it right now, it turns this point data to this image. So what I want to do with these data. The first thing I need to do is, let me just put them all together. I want to create a surface out of this image. But I also want to tell the algorithm that do not use this black part, which is coming from the PNG data, and just use this white part. I mean, the white again here, let's call it grayscale. This grayscale part to create the height differences. So the first thing I need to do is to have these Z differences, these height differences, so that I can construct another point set, as you can see here. So to have this point set, I'm doing it again, very basic construct point. Construct point here. Okay. So I already have my X and Y coordinates. They are coming from my point. So if I deconstruct it once more, actually, I don't even have to deconstruct it, but since I cannot have these lists as inputs, I deconstruct this point once more to get the X and Y inputs. And for the Z coordinates, since I have it here, I will use a multiplication tool to just highlight these level differences a little bit more. I mean, you can even just take directly the input from here, but I didn't like the result and I want to see a bolder one. That's why I make a multiplication, and since my computer tends to crash, I keep it like 5, but according to the size of your grid and image, of course, these numbers can change. I think you all know the drill. So I take this multiplication output as the Z coordinate of my new point set. So after I do this, let's close the eye of these parts. So after I do this, as you can see, I have these contrast part of my image with level differences. Now we are ready to get our surface from our points. And as we all know, the very basic procedure, if you want to get points, if you want to use points to get a surface, and even if we don't know Grasshopper, if we write points and surface, it will get us surface from points. So, and if you don't want to use double click, you can find it from the very basic friendly surface tools. Okay, here. So, or double click and write just surface from points, this one. Okay, so it's asking me the points for the input. As I already have my constructed points, I will reconnect these points to the input, and it's asking me for a U count. And I already have my U count, okay, here. Of course, according to your series and your cross-reference listing, your U count can change. But since in our case, we will be working with square images, I think it won't be a problem. But it must match your U count here. So after, let me just close it and open this one. After I connect them, here we have our beautiful surface. You see how beautiful it is. And the great thing is it's parametric so that we can work with these heights. I'm afraid to change these parameters now since I'm all sharing the screen and changing the parameter. I think my computer will crash, but if you change this parameter, you will see how beautiful to watch the changes in your image. And since our image has a black background, we only have our object in the height map. That's why actually we were cropping the image, because if we haven't cropped the image, then the background could also tend to have height maps. I mean, after this part, actually you can just bake it and clear the outer part in Rhino, but it won't be challenging enough for us. That's why we also want to crop the outer part in Grasshopper, because why not? So here you don't have to do this. I just want to group the things. That's why I connect this one to a surface once more. So I don't want this outer part. What I need to do is dividing my surface first. Actually, before divide, okay. Dividing the surface. Let me just open this one. Why? Because by dividing the surface, of course, the tool is divide surface. According to the U and V count you like, you can just change the U and V count. Like they don't have to be the same, but it was working for me for this image to be the same. So I want to keep it simple. So in your case, if you need something else, please change it according to the shape. You see here, when I divide it with 20, all of these spots are looking great for my image. That's why I keep it that simple. So after I divided, what I did was tell the algorithm to delete the unnecessary ones. To define these unnecessary ones, I use cool pattern. These cool pattern, cool surface, cool pattern, cool faces, cool index, cool vertices, they are all used to get rid of the things we did not want in a list, or maybe don't call it a list. It doesn't have to be a list, but get rid of, they are used all to get rid of the things we don't want. So I use cool pattern here, and as a list input, I use my points, since I don't want to use these unnecessary ones, other than the height, the Z ones, and to the pattern it will be using. Of course, I deconstruct the points once more and use their Z components to tell that from this list, just get the Z ones to cool the pattern. Okay, let's see it once more. And then I just flatten it. So now I have my list of the desired points, and I have my surface. Actually, what you can do easily is just, after creating this surface, just baking it, and with very basic Boolean or surface cutting procedures, you can easily cut it in Rhino. Or you can just use a very basic splitting, breadth splitting tools in Grasshopper by just drawing a very simple curve here in Rhino. But still, we didn't want to do that. We want to do everything in Grasshopper. That's why we make it much more complicated and use this list of our desired points to create the area, the selection area that we will use and get rid of the outer parts. The problem here is, maybe you can ask that, why don't you use these points to create the surface from the beginning? But the thing is with this surface from points too, is that it needs a base to create this curve, these Z dimension. That's why it won't be possible to use just these selected points. Maybe in the, after the presentation, you can check it. But if you use just these points, it won't give you the surface because it's not, it's not having a ground. And that's why we are not using them. So to create this area as the selected area that will be cut from all of the surface, I just use project points to get all of the points to ground, to project them as in its name. Here, as you can see, in the after project points, we have everything on the ground. Now, and to project points, of course, the input is my cal pattern list. And the geometry that it will be projected is, of course, my surface output. And now what I want to do is, I can either draw a curve from the outer points of it. But in our case, since, I mean, in this one, I can easily draw this curve, but when I think of it, maybe some of you don't have a shape this clear. That's why I think it will be a little bit problematic. And I thought that it will be greater if we use a surface instead of a curve to split the VREP. That's why I use diagonal edges, which is here, the very basic mesh component list. And it basically creates, let's open it, these diagonal edges so that we can tell to use everything inside of it. And to the point input, of course, I get these project point output. And then after that, I just basically created a boundary surface out of those edges from the surface component. Okay. Is it clear until now? When you think of it, it's not that complicated. It's very, very basic. But since we want to make it complicated, that's why it's that long. What we need to do next is to extrude this surface. Why? Because the next step, the next tool, split grab, is actually you don't have to extrude it to split a grab, but if you extrude it, I think it's working much more cleaner, and it will be great to see exactly where you're gonna cut from the shape. That's why I always tend to use the extrude. Of course, the extrusion value is not important here. The important thing is just see the outcome of it. And please keep it just a little bit higher than your Z value. It doesn't have to be this high. It's just an exaggeration that I made. So I connect my surface to this and my extrusion as the cutter. So after this, this process, now I'm closing everything. So after this, you see I have this very little thin edge that is showing me that now I have two separate VREFs here. And if we add a panel here and check, you can see that I have two trimmed surfaces, which is exactly what I want. And to get the one I need from these two surfaces, I just use basic list item and connect the result as an input to the list. And of course, I have two surfaces, so I add an additional one here. And when I check them, you can see this first one is the outer part. And this second one, I mean, of course, according to your geometry, it can change. Maybe you can select more than once so that you can have three geometries, but in my case, it was two. The second one is the one I will be working with. Why didn't I use Boolean operations here? Because split VREF is giving me the exact surface, and that was what I needed. If I were using the Boolean operations in Grasshopper, when I just cut the extrusion from the surface, it will be filling this outer part, the underneath of the surface. So it will be something like a physical model that we can see all of the layers. But I didn't want to see that part. I didn't want to see the surface with a thickness, with a full outer part. I just want to use the surface. That's why here, actually, I prefer to use this VREF. So from now on, I will be working with my geometry, which is the cropped surface of my creative tree here. Now I'm closing all of these things. Okay. So you don't have to do this again, but I want to group them. That's why I connect this one to a VREF. So now what I need to do is I will play with it. So I have something that can be called three-dimensional. Actually, it's 2.5 kindish right now, but I don't have a cup. And I want to create something similar to a cup because I started working with a cup and I want to get something out of it that resembles a cup. But in your case, it can be something different. Like you can start with a cup and you want to get a plate, maybe. It can differ. But in my case, I want to get a cup. So that's why the next steps will be about taking this surface, or maybe more than one surface, and turn it into something like a cup. Let me just check it. Okay. So the first thing, again, is dividing the surface. Why? Because I want to use its point. Because the thing is, now I want to take this surface. I want to take this surface and just merge it into another surface that will help me to turn it into something like a cup. In my case, that will be a cylinder, a very basic cylinder, because I needed to have a hole. And since we are, from the beginning, since we are working with the topology, and I want to create something with just one hole because of the cup. And I want to take this surface and merge it onto a cylinder. In your case, it can be a box. It can be something that has a non-uniform shape, anything you can think of. So to merge it onto a cylinder surface, I will be using surface morph. And to surface morph it, let's check it. To morph it into another surface, I will need my geometry. I will need the reference, which will be showing where to take it and where to put it. And I will need a surface. In my case, it is the cylinder. And again, I will need U, V, and W domains. So let's prepare this set. The first thing is my geometry. I already have it. Let's check it here. My geometry is my boundary representation, which is my surface. So I connected it. So the references, when you come and wait a little bit, it's telling you to have a box. So in my case, since it's a non-uniform shape, I should create a bounding box. A very basic bounding box. Let's see it. So when I double click and write bounding box, the very basic bounding box I'm talking about, and to its content, I connect my direct, it's creating my bounding box. So now my reference is also ready. Now I'm connecting it to this reference. Let's close it. So the surface, the third thing is the surface. It will be my cylinder. It will be the second geometry, the second surface that you will be morphing your original geometry. So now here I created a very basic cylinder, as you can see here, and give it my desired radius and length according to your taste and shape. It can change. And I connected it to surface. Ayşegül Hocam, welcome.
Hello.
We can hear you. I just wanted to warn you.
Yeah.
Okay. Okay. Now, what about these U, V, and W inputs? Let's go and check these things. So, of course, for U and V counts and the Z counts, I mean, here it's, of course, the W, we will be using our original direct. So to use its dimensions, what I need to do is first divide it according to the slice you want. Actually, this one doesn't matter that much. Let me close these things also. Okay, so after I divide it, of course, I get my points. According to your division, the end result, the perfection of the end result will change. But again, from the beginning, as I repeat, it doesn't have to be that perfect, and you don't have to just force your computer that much. That's why I keep it a little bit low. So after I divide the surface, I use my points and deconstruct them to get the W domain, to get their Z levels. Because I already have the U and V domain from the sizes of my cylinder. As you can see, when I deconstruct this cylinder, but deconstruct square, because it's a three-dimensional object, I can take the U and V components because I want to merge it just around the cylinder. So, of course, it's very obvious that I will be using its X and Y dimensions. But for the Z dimension, which is here the W domain, I want to use my heights. That's why I get the Z components of my surface. Okay. So after I connect all of these things to input, what I get is, let's close this part and let's open my cylinder maybe. Here you can see my cylinder. And here you can see that it's morphing everything around my cylinder. Okay. So the thing here is, here. Let's check. Yes. The thing here is, when you just divide it, I mean, according to your surface shape, it changes. When you divide it, and if the cylinder is small, as it is in my case, it tends to just keep wrapping those divisions around the cylinder. That's why if you see something similar to this, like if you see something more than one layer, it's because of that. And in that case, please go and change the U and V counts of the divide surface value so that you can have just one surface. But of course, if you like to just have more than one surface, then it will be great for you. And if you just put different numbers to U and V count, you can see you will have some inspirational different results. But now, since I don't want to crash my computer once more, I will keep it this simple. So at the end of it, after I just morph the geometry around the surface of the cylinder, I will have my geometry. And when as you can see here, it has 3 surfaces. One of them is around the cylinder itself, and the other one is here, and the third one is at the outer part of the cylinder. That's why we have these 3 geometries. If you like to work them as one, you can basically use this direct join just for this geometry, or you can keep working on it as it is. Now, actually, this is the part you will be doing. And if you like, let's make it and see. Just one. Let's make it here. And see. So I have something similar to a cup. And when I check my first image, I think they look quite, not quite similar, but it resembles, it gives you the idea that the outcome of your AI procedure would look something like this. So let's delete this one. If you want to add other surfaces, what you need to do is just basically you can copy everything, and let me just open this surface morph one. Okay. And I can change this parameter in this one also. Okay. So here, I think I have 2 overlapping ones. Anyways, if you don't want to use them as overlapping ones, of course, you don't want to use them as overlapping ones, you can basically rotate your cylinder here. And if you haven't used rotation before, we are using the very basic rotate tool and connect our geometry to the input of it. And for its angle, if you want to use numeric angles like 90 degrees and like 45 degrees, something like this, you just need to right-click the word angle and select degrees from here so that you can work with basic degrees. And what I did here is just connecting a 90 degree here. So when I change it, I don't know why I cannot see it. Why I cannot see it? Can you see it in your computer? Interesting. I think it's just given a nonsense warning about it, because let me copy everything and do it once more. Okay. Okay. So what I did here is just rotate the cylinder and turn this one to say 40 degrees. Is it turning? Yes, it's turning, but why? Okay, and connect these rotated geometry to domain and to my surface. I found the missing part. Okay, so from now on, when I turn it, I can see that the geometry is turning. Actually, it's very basic and too obvious. And the outcome is this. And if you like if you have 3 or more, whatever number of VREBs, if you want to use them together, you can just join them by using another VREB join, maybe. So here, this one and this one. And you can just basically bake it to see the final result. Here we have our cup. And it's 3D printable. And we have a 3D printed one. Let me show you.
Oh, so cute. We will cry right now.
And when you do it, it will look something like this. But you see, it's a cup and it's an actual product and it's 3D printed. And that's the great thing about it. I took the AI outcomes of Ayşegül Hoca and just create a very basic algorithm and create something that resembles an actual product that is, again, a cup. That made me quite happy.